So the purpose of the following video today is to show you how to generate a scatter plot in Excel. So just as always, make sure that you have your Excel spreadsheet open and directions in the Word document available so you can follow along and replicate what I do. You're welcome, of course, just like any other example for Excel, to pause the video at any time to perform calculations or if you get behind so that you can catch up. Now, with any spreadsheet that we open, remember the first step that we always want to do is want to take a look at the code book and make sure we understand the variables that are being measured, how they're being measured, and what they represent. So I'm going to go ahead and go down to our code book down here in our spreadsheet. And we're going to see the scenario here, which we'll take a look at, and then we'll look at our two variables. So in this scenario, suppose we want to know if absences predict a student's course grade. We decide to measure the number of days missed and the course grade for each student in an introductory statistics course at Auburn University. So note here we're only looking at one semester. In the lesson earlier you saw the course grades and absences over several semesters. I think it was over 6 semesters. And so our question here is, do absences seem to matter in statistics courses? In other words, does it seem to predict grades in statistics courses? So let's use an alpha of 0.05 to answer this particular question. Now for this particular video, we're not actually going to go through the correlation and the regression. We'll save that for the next video. We're really going to focus on the scatter plot here today in the last two assumptions, linearity and equal variance. And so that's going to be our focus for today. Now again, if you're looking at our individual variables, we have a variable called absences, which is the number of absences in a semester. And then we have the other variable, which is grades, which is the current course grade of the students. Then that very first variable is just a participant identification number. This would just be identifying the student, not by name, but by number. So if we look at our data here, we'll see that we have, it looks like 78 students, and we have the number of absences they have in the semester, as well as their course grade. Now, when you are doing correlation and regression, you do have to make sure that you have pairs of data. So if in order to do a correlation, each observation or each participant has to have two values, one for each of the variables. So we always want to make sure that we're checking that. And so you'll see that in our step 1 in our directions, right? And we'll just do step 1 and 2 today in this video. We'll save step 3 and step 4 for another video. But in step 1, we're going to make sure that we have two values for every observation. And then to do that, we can either just scroll through and see if there's any blank cells. In a small data set like this works just fine. Doesn't look like there's any blank cells here. But if we had a much larger data set, maybe it was like thousands of observations, then scrolling through wouldn't be a very efficient way to do it. The best way to do it then would be to sort each of your columns, which we've talked about before in this class. So again, on that home tab, we have that sort and filter. So we can sort smallest to largest, sort for our very first variable, in this case absences. You can then scroll down to the bottom and see if there's any empty or missing cells. So in this case there isn't, and so we'll go ahead and sort the next column, the next variable. But if there was, right, we would delete the observations, so we'll delete the rows for those observations if there were some missing values in that particular variable. So that one looks good. We'll go ahead and sort the other one just for practice. We already looked at it. We know we don't have any missing data here. But we'll still sort it just for the sake of practice and scroll down and see that there doesn't appear to be any missing values or cells here. Again, if there was, we would highlight and remove the entire observation, because in order for us to do the correlation or regression, we need to have pairs of data, one for each one of the variables that are being measured for each one of our participants. Okay, I'm just going to sort the participant ID number, just put it back in its original state. We don't necessarily need to do that. But it just moves it back to how it was when we first started with the data set. So we don't have any missing values here, so we can go ahead and continue on to step number 2. So to step number 2, we're actually going to create the scatter plot that we're going to use for those last two assumptions. Assumption 4, which is linearity of our variables, and assumption 5, which is equal variance. So to do this, we'll select the columns that we want to include in the scatter plot. So we're just going to highlight those columns. We'll click on our Insert tab. We'll select the icon for a scatter plot under Charts, and we'll go ahead and select the very first option. Once we do that, we'll click on the scatter plot and then go to Quick Layout. That way we can get our labels and titles for the graph. There, under the Quick Layout, we'll select the very first option. When we do that, there will be some additional background noise in that particular graph. So we're going to remove that chart junk right, which would be the background lines and then also the legend. And then we're going to add in the title and labels, and that will give us our scatter plot. And once we have that scatter plot, we'll use it then to interpret our last two assumptions. All right, so let's go ahead and do it. Let's go to our spreadsheet here. We're going to highlight those two variables that we're going to include in the scatter plot. We're going to go up to Insert, the Insert tab, and we're going to go to our charts. You can notice there's several different options here, but you're going to see one that has this scatter plot. The little dots here on this XY axis, that's the one that we particularly want. If you hover over it, it'll say Insert Scatter or Bubble Chart. Again, we're looking for the scatter plot, which would be the scatter XY axis. And there's several different options here, and so we want that very first one. That's right here. So we'll go ahead and select it. Notice it gives you a preview there. But you'll notice in this particular graph that we don't have any labels for the X and the Y axis. So we need to make sure we add those. So I'm just going to click on the graph here. And when I do that, you'll notice that the chart design icon pops up here in the tabs. And I can go over here to quick layout. And there are several different layouts there. The one that I want to use is going to be this very first option here. Once I have that selected, you're going to notice that there's these lines in the back as well as this legend. We call this chart junk. It doesn't do anything but make the graph look more complicated, so we're going to go ahead and get rid of those, just that it makes our graph look a little bit cleaner and crisper when it comes to viewing it for our audience. So all I had to do there was just click on one of the lines in the background. And once I did that, all the lines were highlighted, and I just hit delete on my keyboard. I can do the same thing with the legend. Just click on the legend. And then if I hit delete, I'll get rid of that legend as well. So our scatter plot looks pretty good here. We do need to give it some labels. So on our x-axis, that's going to represent that very first column that we highlighted for the scatter plot. So this is going to be our number of absences, right, in the course. The y-axis here, the label is going to represent the dependent variable, or in this particular case, that second column, which is going to be grades. We'll just type in grades there. And of course, we do need to give it a title. The title should reflect both the x and the y axis, as well as the population of interest. So we can say here, I'll highlight it, college student grades predicted by absences. Now you could also say college student grades correlated with absences. That'd be perfectly fine as well. This as long as we're including both the labels for the x and y axis and identifying who our population is. All right, so there is our scatter plot, and that's as far as we'll go for as what we do in Excel here for this particular video. But let's take a minute and let's try to interpret this particular graph. So remember that the assumption number 4 is that your variables are linearly related to each other. So what we mean by that is that if we were to draw a single line through our data points, right, and it doesn't have to touch every data point, it's just a line of best fit, would that line of best fit be a straight line or would it be a curved line? If it's a straight line, then we would say it's a linear relationship. If it's a curved line, we'll say it's a nonlinear or curvilinear relationship. And so as I look at this particular graph here, this looks very much like a straight line relationship. I'm not seeing any obvious curves if I was to draw a line that's measured by a mathematical function. And so in this particular case, this looks like very much a straight line. Now, if we had a graph that maybe there was some absences, as absences increase, there's a slight decrease in grades, but then after a certain number of absences, like 8 or 10, it just drastically decreased and plummeted, well, that would be a nonlinear trend. So if you're looking at my cursor, right, it would curve down. That would be nonlinear, it'd be curvilinear relationship, and that would violate the assumption. But here, this looks very, very straight here for the most part, right? Again, it's not going to go through every point in the scatter plot. It's just generally what is the trend when it comes to grades and absences. And it looks like in this particular case is that as absences increase, grades tend to decrease at a constant or steady rate. And that's how I would word it when it comes to the assumption if I have a linear relationship. If I had a curvilinear relationship like the one we were talking about earlier, where it kind of nosedives down and it makes a curve there, we might say that as absences increase, the grades decrease at an exponential rate. And that would indicate a nonlinear type relationship. All right, so that would be assumption number 4. Let's talk about assumption number 5 here. Assumption number 5 is equal variance. So what we mean by that is that the spread in the values or the observations should be the same at every level, or roughly every level of that predictor variable or that x variable, that independent variable here on the x-axis. So that means that the spread here around 0 and 2 absences should be roughly the same. Again, looking vertically, the spread in grades should be roughly the same when absences are maybe 6 through 8 or 10 through 12 or 14 through 16, whatever it may be. So anywhere along that line of best fit, the spread in values should be roughly the same. Now, it's never going to be perfectly the same, and that's not what the assumption is asking. The assumption is asking generally, is the spread in grades, is the spread in your dependent variable roughly the same? In this case, it looks pretty good, right? So remember in the lesson, it showed that as absences are increasing, the spread in grades was increasing as well. Here it actually stays pretty steady, that if I'm looking at absences around 3, right, it looks like grades are somewhere between maybe a 78 and it looks like 100, right, percent, which would be about 22 percentage points differences. But we'll see that generally that's going to hold throughout, that if I'm looking here and at the other end, that maybe here in the where absences are about 10, we'll see that grades tend to be, looks like maybe around 70, right? All the way up to maybe 85 or 86. And so that gives us a difference of about 10, 15, maybe 16 percentage points, which isn't very much different than our 22. No way does it look like it is narrowing significantly, nor does it look like it's spreading out significantly as we go from left to right when it comes to absences. And so I usually kind of say this, I say, cross your vision, blur your eyes, whatever it may be, right? So that you can get a general sense of what that relationship looks like between grades and absences when it comes to the spread. And here the spread stays roughly the same as we go from left to right on our graph. So in this particular example, with this one semester, it appears that we are meeting assumption number 4. It does look like a linear relationship. A straight line best represents the relationship between absences and grades. And it also looks like in this particular semester, in this particular example, that the variances are roughly the same, that at any point in absences, the spread in grades is about the same, generally looking across our graph. Again, it doesn't have to be perfect, right? Just blur your vision, cross your eyes. Generally, does it look like it's equal? And if so, we're meeting that particular assumption. Now, I'm not expecting you to be perfect with your interpretations for assumptions 4 and 5. I'm actually more interested in your explanation. Does your explanation demonstrate that you know what linearity is? Does your explanation demonstrate you know what equal variance is? I'm less concerned if you get it completely right, because there is some subjectivity to interpreting assumptions 4 and 5 when it comes to correlation and regression. All right, so that does it for this particular video. We'll come back, we'll look at regression, the last 2 steps in our directions in the next video. Thank you.